Welcome to Brain Vision.
First things we want to do is look up the average linear expansion coefficient for these copper pipes in the textbook. So that alpha is going to be equal to 17 times 10 to the negative 6. That's going to be in inverse degrees Celsius. And we can calculate delta T by subtracting Ti from Tf. And that's going to be equal to 28.5 degrees Celsius. Now to find how much each section of the pipe expands, we can use the equation delta L is equal to alpha times the initial length times delta T, and substitute in H and L, lowercase l, instead of our big L and Li. So let's start with H. Delta H is going to be equal to alpha, which is 17 times 10 to the negative 6. Initial H, 0.28 meters, times our change in temperature, 28.5 degrees Celsius. So delta H is equal to 1.36 times 10 to the negative 4 meters. Now for L, delta L is equal to, well, again, same in linear expansion coefficient, 17 times 10 to the negative 6 times 1.34 meters times 28.5 degrees Celsius. So our change in L is equal to 6.49 times 10 to the negative 4 meters. Now, if we want to find the magnitude of how much the elbow moves, or the displacement, we need to put in both our delta H and our delta L, square them, add them together, and put them under a square root to find magnitude. So when we plug in our numbers, delta H 1.36 times 10 to the negative 4 squared plus delta L 6.49 times 10 to the negative 4 squared. You should find the magnitude of displacement. I'm just going to label this D for displacement is equal to 6.63 times 10 to the negative 4 meters. Now for the direction, we can just find an angle theta, and we can find the direction through the inverse tangent. It's kind of confusing that L is in the y direction and H is in the x direction in this example, because you would figure H is height, which is y direction, but we kind of need to change these in our inverse tangent, or flip them around, right? So theta is the inverse tangent of delta L over delta H, which is equal to the inverse tangent of 6.49 times 10 to the negative 4 over 1.36 times 10 to the negative 4. And you should find that our position, or I guess direction of displacement in this case, is going to be equal to 78.2 degrees.